So on the Result Ribbon tab, in the Interactive Grouping, select Results Grid. And I'm going to expand mine a bit here. And go ahead and select the Code Stresses tab. The results grid is very nice because we have some filtering options on the right and sorting options. So from the combination filtering, I'm going to select all, and I'm going to go through and select a couple of combinations to compare. I'll select Sustain plus E1 in the first analysis set, Sustain plus E1 in the second analysis set, and Sustain plus E1 in the third analysis set. So we're not so much focusing on our results passing or failing in this class, but more about comparing load combinations and load cases that might look the same, but actually produce different results, and understanding the reason for that. So we're comparing a load combination here that is exactly the same terminology, except for the number in the brackets, which represents the analysis set. And following the workbook on page 15, we'll focus on point A3 here. And we notice that Sustain plus E1 in the first analysis set produces a stress of 8,901 psi. In the second analysis set, it produces a stress of 10,167 psi. And in the third analysis set, it produces a stress of 9,132 psi. So all different values. The reason for this is based on the fact that the first analysis set is looking at earthquake in the ambient state, just looking at gravity. The second analysis set is looking at the earthquake in the operating state for operating case 1. Operating case 1 is considering the temperature at 320 degrees Fahrenheit. And the third analysis set is considering the earthquake occurring while the piping is in operating case 2, while the pipe temperature is at 550 degrees Fahrenheit. So if the earthquake hits at these 3 different points in operation and shutdown state, it will yield different results from our piping. Our piping is starting at a different point when the earthquake hits, so it yields different results, even though it might be the same earthquake hitting the piping. We'll dig down into this a little bit further by looking at the support forces. So let's select the support tab here. And again, let's filter this. So on the right side, let's uncheck select all for support types and just click inclined. And for combinations, let's uncheck select all. Let's take a quick look at our piping model again. We are going to focus on this support here. This support has an incline lateral Z direction support that has a gap in both the positive and negative Z directions of 1 inch and a friction coefficient of 0.3. We're going to use this support as our main example here, but you could do this with any of the supports. Very often a lateral support is where you'll see the biggest influence of using load sequencing. So if I open my results grid again and get back to my support tab where I was, again, I want to filter my supports to inclined, and I want to filter my combinations to just my occasional loads. So static seismic 1, wind 1, and wind 2 in the first analysis set. Static seismic 1, wind 1, and wind 2 in the second analysis set. And static seismic 1, wind 1, and wind 2 in the third analysis set. Again, I'm going to focus on A3 up at the top. And we see these results on page 16 in the workbook. So we really want to focus on the fact that just because, again, our naming of our combination might be the same, doesn't mean we would get the same results. Here's my static 1 case in the 3 different analysis sets. And if I focus on the Z force, we can see that in the first analysis set, my Z force is 0. In the second analysis set, my z-force is 0. And in the third analysis set, my z-force is negative 136 pounds. So the different initial states produce different forces from the same load being applied. We'll dig deeper into an example, but this is just a quick look. So next what we can do is let's again come up to the top of the combinations and check on and then uncheck select all to clear the selection again. And let's come down and pick our operating cases with occasional loads. So GE1 in analysis set 1, GW1 and GW2 in analysis set 1, GT1E1, GT1W1 and GT1W2 in analysis set 2, and GT2E1, GT2W1 and GT2W2 in analysis set 3. This is focusing on the fact that, again, AutoPipe, based on how we created our analysis sets correctly, and it's easy now to create our analysis sets correctly for nonlinear load sequencing because our new analysis set editor helps us to do that. So when we create them correctly, we automatically get correct results. We get correct combinations. Again, just focusing on how in analysis set 1, we have our occasional loads being combined automatically with gravity. In analysis set 2, we have our occasional loads being combined automatically with gravity in the thermal 1 case. And in an analysis set 3, we have our occasional loads being combined automatically with the gravity and thermal 2 case.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.